Have you ever stared at statistics problem and wonder when exactly do I use t-test? Or maybe you've heard about one sample t-test, two sample t-test, but all sound confusing? Well, don't worry. In today's video, we are breaking it all down step by step with real-life examples and clear solutions. By the end of this video, you'll be confidently solving t-test problems like a pro. So let's dive in. Now let's define what a t-test is. A t-test is a statistical test used to compare means between groups. Now let's look at when to use t-test. We use t-test when the sample size is small, typically less than 30, and when the population standard deviation is unknown. That is when we don't know the population standard deviation. T-tests are extremely useful in real life, from comparing drug effectiveness to comparing students' performance before and after training, and so on. This brings us to various types of t-tests. Firstly, we have one sample t-test. One sample t-test compares a sample mean to a known population mean or a fixed value. Second type of t-test is two sample t-test. There are two variations of two sample t-test. The first one known as independent or called unpaired two sample t-test, while the second one is dependent, also called a paired two sample t-test. Independent or unpaired two sample t-test compares the means of two independent, say different or unrelated groups. For example, comparing the male and female scores. Comparing the average height of students in two different schools is a good example of independent or unpaired two sample t-test. Another variation of two sample t-test is the dependent or the paired two sample t-test. This t-test compares the means or the same group before and after treatment. Comparing your weight before and after gym is a good example of dependent or the paired two sample t-test. Please note, the choice between these two, that is the independent and the dependent two sample t-test, depends on whether the samples being compared are related or not. Additionally, there are two variations of the unpaired two sample t-test, depending on whether the variances of the two populations are assumed to be equal or unequal. Therefore, two sample t-tests of equal variances assumes that the two groups being compared have the same variance, while two sample t-tests of unequal variance assumes that the two groups being compared have different variance. This is known as the Welch t-test. This brings us to different formulas of t-test based on the type. Formula for one sample t-test is sample mean minus population mean divided by standard error. Of course, standard error is standard deviation divided by root n. Therefore, for one sample t-test, the formula could as well be sample mean minus population mean over standard deviation divided by root n. For independent two sample t-tests of unequal variance, the formula is mean of the first group minus mean of the second group divided by square root of variance of the first group divided by n1 being the sample size for group 1 plus variance of the second group divided by n2, n2 being the sample size for the second group. However, if the sample variance are equal and the sample size is also equal, the independent two sample t-test formula will be slightly different, as poor variance calculations will be used. Therefore, if the sample variance is assumed to be equal and sample size equal, this formula will be adopted in calculating t. Mean of first group minus mean of second group divided by square root of 2 multiplied by poor variance divided by n. On the other hand, when sample variance is equal while sample size is unequal, we adopt this formula in calculating the t. Mean of first group minus mean of second group divided by square root of poor variance divided by n1 plus poor variance divided by n2. For a dependent two sample t-test, t is calculated using this formula, mean difference over standard deviation divided by root n. Let's solve some numerical problems involving various types of t-test. A battery company claims 8 batteries last 10 hours on average. You test a random sample of 8 batteries and you get these lifespans in hours: 9.5, 9.7, 10.1, 9.6, 9.8, 9.9, 9.4, lastly 9.6. Test the hypothesis, which states that the average lifespan of the battery is 10 hours. At 0.05 level of significance, first thing to do is to state the hypothesis. We'll start with the null hypothesis. This hypothesis states that the mean battery lifespan is actually 10 hours, while the alternative hypothesis states that the mean battery lifespan is not 10 hours. Choose the significance level. We are asked to test at 0.05 level of significance. So the alpha is 0.05. Find the sample mean. And we are given this range of values. So sample mean will be 9.5 plus 9.7 plus dex plus dex plus dex plus dex plus dex plus dex. 77.6 divide by n. N means the sample size, which is 1, 2, 3, 4, 5, 6, 7, 8. So 77.6 divided by 8 gives 9.7. Next is to find the sample standard deviation. This is the shortcut formula used in finding the standard deviation of sample data. Looking at this formula, we have summation x squared. We are given this range of values, which serves as x. Now we'll figure out what the s squared values is gonna be. 9.5 square, 9.7 square, 10.1 square, the square of 9.6, square of 9.8, square of 9.9, square of 9.4, square of 9.6. Now going back to our formula, we could see summation x squared. So we're expected to sum up all the s squared values. 90.25 plus dex 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 gives this, and then we have minus summation x all square. Remember, we got summation x value to be 77.6, so 77.6 square gives this, and then divide by n. N value is 8, that is the sample size. So this value divided by 8 gives this. Divide by n minus 1. We did say our n value is 8. 8 minus 1 gives 7. 753.08 minus 752.72 gives 0.36. 0.36 divided by 7. Square root of this value is approximately 0.23. Therefore, the standard deviation value is 0.23. Step 5 is to calculate the t-statistic. Since we are dealing with one sample t-test, we adopt this formula to calculate the t-statistic. We have S mean. X mean value is 9.7 minus the population mean. In the given question, we are told that the battery lasts for 10 hours on average. So the population mean value is 10 over standard deviation value divided by root n. N value is 8. Square root of 8 gives 9.7 minus 10. 0.23 divided by this value minus 0.3 divided by this is approximately negative 3.7. So negative 3.7 represents the t calculated. Find the degrees of freedom. Degrees of freedom is calculated using this formula, n minus 1. And our n value is 8. So 8 minus 1, 7. Find the critical value from t distribution table. These are t distribution table. We are looking at degree of freedom 7, 2 t-tests at alpha 0.05. Compare t value, that is the t calculated, to the critical value and take decision either to reject or do not reject null hypothesis. Since t value is less than the critical value, we reject the null hypothesis and conclude there is a significant difference from the claimed 10 hours. That is, the claim that the battery lasts for 10 hours on average may be false. Let's solve the second challenge that involves independent unpaired two sample t-tests of unequal variance. The table below is the mass scores of two classes using different teaching methods for class A and class B. Test the hypothesis that there is no difference in population means at 0.05 significance level. Now let's sum up group A. 78 plus dex plus dex plus dex plus dex. Sum for group B will be 70 plus dex plus dex plus dex plus dex. Class A sample size is 5 because we have 1, 2, 3, 4, 5. So also for class B. Compute mean for class A and class B. Applying this formula, mean for class A will be sum of A divided by n, that is the sample size. Mean for the second group will be the sum of B divided by sample size. Let's square each of the group values. 78 square, 75 square, 80 square, 74 square, 77 square. Sum this together. 6084 plus dex plus dex plus dex plus dex gives this value. Square of 70, square of dex, square of dex, square of 79, 4900 plus dex plus dex plus dex plus dex gives dex. Squaring this value and dividing by n1 will be 384 squared divided by 5. Squaring this value and dividing by n2 gives, since we have equal sample size, the n minus 1 will be 4. Calculate the sample variance for each group using this formula. Variance for group A will be summation x squared minus summation x all squared divided by n, which will get dex. So this value minus dex divided by n minus 1, 22.8 divided by 4, 5.7. Let's also compute variance for group 2. Summation x squared minus summation x all squared divided by n. This value minus dex, 17.2 divided by 4, 4.3. Now let's find t statistics with this formula. Mean of class A, 76.8 minus mean of class B, 70.4 divided by square root of variance of class A over sample size for class A, 5 plus variance for class B divided by sample size for class B, 76.8 minus 70.4 divided by square root of 5.7 divided by 5 plus 4.3 divided by 5. 1.14 plus 0.66 gives square root of 1.8. So 6.4 divided by 1.35, approximately 4.74. Now let's calculate degrees of freedom. Because we're dealing with two sample t-tests, degree of freedom will be n1. n1 value is 5 plus n2. n2 value is also 5, then minus 2. 5 plus 5 is 10. 10 minus 2, 8. Now let's find t critical from t distribution table. At degree of freedom 8 and alpha at 0.05, at this point, that is 2.306. From the table, the critical value at alpha at 0.05, two-tailed is 2.306. Comparing t critical value with t statistic, we'll make a decision either to reject or do not reject null. Calculated is greater than the critical value. We reject null and conclude. Let's solve numerical problem that involves independent two-sample t-tests of equal variance and equal sample size. A researcher wants to determine whether two different teaching methods lead to significantly different students' performance in tests. She randomly assigns 10 students to each method and records their test scores. Determine if there is a significant difference between the means at 5% level, assuming equal variances. State the hypothesis. Non-hypothesis states that there is no difference in mean scores, while alternative states that mean scores are significantly different. Sum each of the groups. 78 plus dex plus dex plus dex plus dex plus dex plus 84 plus dex plus dex plus dex. 72 plus dex plus dex plus dex plus dex plus dex plus 75 plus dex plus dex plus dex. Find the sample size. Of course, we have equal sample size for the group. For method E, the sample size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So also for method F, this entails that n1 is equal n2. Finding the mean for the first group will be summation x 815 divided by 10 equal 81.5. Mean for second group will be this value divided by 10, 71.4. Squaring each sum and dividing by n value for the first group will be 815 square divided by 10. Square of 815 gives this value, and then divide by 10. Taking the square of summation of group 2, dividing by n, 714 square gives this, then divide by 10. Now let's find the square of each of the groups. 78 square, 82 square, 85 square, 88 square, 75 square, 79 square, 80 square, 81 square, 83 square. Sum of these values. 6084 plus dex 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 gives this value. Let's get the square of each of these values. 72 square, 70 square, 69 square, 73 square, 68 square, 71 square, 75 square, 74 square, 72 square. Let's list 70 square. Now let's sum all these values. 5185 plus dex 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 plus dex, lastly plus dex. Let's find sum of squares for the first method. Sum of square for group 1 is equal this value minus this value, 126.5. Also, we'll get sum of squares for group 2, which is this value minus this value, 4.4. Now, let's find degrees of freedom. Since sample sizes are equal, our degrees of freedom will be 2n minus 2. That is 2 multiplied by n, and n value is 10. 2 times 10 gives 20. 20 minus 2 gives 18. Now we'll calculate both variance using this formula. Sum of squares for group 1, which is dex, plus sum of squares for group 2, divided by degrees of freedom. So 126.5 plus 44.5 divided by 18 is approximately 9.494. Multiplying both variance by 2 gives approximately 18.988. Dividing 2 multiplied by both variance by n value, remember our n value is 10, gives approximately 1.898. Now let's find this statistic using this formula. Mean for the first method minus mean for second method. 81.5 minus 71.4 divided by square root of 2 multiplied by both variance divided by n, which gives 1.898. Square root of 1.898 is approximately 1.378. 10.1 divided by 1.378 is approximately 7.32. Now, let's find T critical from T distribution table at alpha as 0.05 and at degree of freedom 18. T distribution table we have degree of freedom 18. Two-T test at alpha is 0.05. So we trace this then to 18, 2.101. Let's compare T calculated with T critical and make decision either to reject or do not reject null. Since T calculated value is greater than T critical value, we reject the null hypothesis and conclude that there is a statistically significant difference between the two teaching methods. That is, teaching methods do not impact students' performance. Before we proceed to the next challenge, guys, if you are getting value from this video so far, please kindly like, and if you are yet to subscribe to my channel, kindly subscribe. Thank you. Now let's solve a numerical problem involving independent two sample t-tests of equal variance and unequal sample size. A clinical trial compares recovery times in days between patients using drug A and drug B. Test the hypothesis that there is no difference in recovery times. Assume equal variances. Firstly, we state the hypothesis. Null hypothesis states that there is no difference in mean recovery time between drug A and drug B, while alternative states that there is difference in mean recovery time between drug A and drug B. Drug A sample size 1, 2, 3, 4, 5, 6, 7, while sample size for drug B will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Summation of drug A will be 12 plus 14 plus dex plus dex plus dex plus dex plus dex. Summation for drug B will be 10 plus 9 plus 11 plus dex plus dex plus dex plus dex plus dex plus dex plus dex. Obviously, the sample sizes are not equal. N1 is not equal N2. That is, N1 is 7 while N2 is 10. Mean for drug A will be this value divided by dex. Mean for drug B will be this value divided by dex. Finding the mean difference will be this value minus this value. Let's take the square of sum of drug A and divide by n value. 92 square divided by 7 is approximately this value. Taking the square of sum of drug B and divided by n value, 99 square divided by 10, 980.1. Taking the square of each of drug A, 12 square, 14 square, 13 square, 11 square, 15 square, 13 square, 14 square. Let's add up these values. 144 plus dex plus dex plus dex plus dex plus dex plus dex gives dex. Let's also take the square of each of these values. 10 square, 9 square, 11 square, 12 square, 10 square, 9 square, 11 square, 10 square, 9 square, Lastly, a square. Adding up these values, we have 100 plus dex 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 plus dex, lastly plus dex, 993. Calculating sum of squares for drug A will be this value minus this value, approximately 10.8571. Sum of squares for drug B will be this value minus this value, 12.9. Since we are dealing with two sample t-tests of unequal sample sizes, our degree of freedom will be n1, 7, plus n2, 10, and then minus 2. So 7 plus 10 gives 17. 17 minus 2, 15. Taking the covariance will be sum of square for group 1 plus sum of squares for group 2 divided by degree of freedom. So this value divided by 15 is approximately this value. Now let's find t-statistic. So because we are dealing with independent two sample t-tests of unequal sample sizes, we'll use this formula in calculating the t-statistic. Mean difference value is there, and then divide by square root of covariance value, divide by n1 value, 7. So this value divided by 7 is approximately 0.2262 plus covariance value, and then divide by n2, 10. Value divided by 10 is approximately 0.1583. 0.2262 plus 0.1583, approximately 0.3846. Square root of this value, approximately 0.6201. This value divided by 0.6201 is approximately 5.229. Let's find the critical value of t at alpha 0.05 and degree of freedom 15. T distribution table. Looking at t-tail at 0.05 level of significance and degree of freedom 15, so we trace it then to 0.05, 2.131. Making comparison between t calculated and t critical value. Obviously, t statistic is greater than t critical. We reject no and conclude that there's a statistically significant difference in mean recovery times between drug A and drug B. That is, drug A's mean is higher. Guys, if you're actually getting value and at this point you're yet to subscribe to my channel, please kindly subscribe and also do well to like this video. Thank you. Now we'll look at how to solve numerical problem involving dependent two sample t-test. A fitness trainer tests the effect of a 1 month training on weight loss. The weights in kilogram of 6 participants before and after the program are as follows. We'll start by stating the hypothesis. The null hypothesis states that the training has no effect on weight. What null is saying is that there is no difference in the weight before and after, while alternative states that the training reduces weight. That is, the weight before is greater than the weight after. Now let's record the number of persons. 1, 2, 3, 4, 5, 6. So n equals 6. Now let's get before and after difference for each participant. We'll represent that with day, and we'll also get the square of day. 80 minus 76. So this square will be 4 square. 85 minus 81. 4 square. 78 minus 75. 3 square. 90 minus 85. 5 square. 88 minus 86. 2 square. Lastly, 82 minus 78, and 4 square, 16. Now let's sum the difference. 4 plus 4 plus 3 plus 5 plus 2 plus 4. Now let's get mean difference, which is summation d value, and then divide by m value. So 22 divided by 6, approximately 3.67. Now let's square summation d value and divide by m value. 22 square divided by 6, approximately 80.67. Now let's sum these square values. 16 plus dex plus dex plus dex plus dex plus dex, 86. Summation d square value, 86 minus summation d all square divided by n. 86 minus 80.67, approximately 5.33. Let's find n minus 1, which is the same thing as degree of freedom. N value is 6 minus 1. Now let's calculate standard deviation of difference using this formula. Square root of summation d square minus summation d all square all over n. We got the value to be 5.33 over n minus 1 value. So this value divided by 5 Square root of 1.067, approximately 1.031. Let's find t statistic with this formula. Mean of difference. Divide by standard deviation of difference value over root n. This value divide by root n. 3.67 divided by 0.42, 8.74. Now let's visit t distribution table at alpha 0.05 and degree of freedom 5. Comparing t-value with the critical value. Since t-value is greater than the critical value, then we reject now. Conclude that the training program significantly reduced weight. I hope this video helps. Please like if you found this video helpful. Comment with any question or topics you will want us to cover in future video. Give this video a thumbs up. And if you are yet to subscribe to my channel, please kindly subscribe. Thanks so much for watching. See you in our next video. Bye.